Alright, so in this problem, I have 8 to the power of x is equal to 16. So I want to find the value of x here. So for my solution, I'm going to start by rewriting my equation here. So my equation is 8 to the power of x is equal to 16. Now, before we start doing anything, let's just inspect this problem real quick. So if I plug in x equals 1 into this equation, I get 8 to the power of 1 is equal to 16, which 8 to the power of 1 is the same thing as 8, so I get 8 equals 16, which is false, right? Now if I plug in x equals 2, I get 8 to the power of 2 is equal to 16, and 8 to the power of 2 is 64. So I get 64 equals 16. And notice how there's a big gap between 8 and 64. So we know that the value of x is not going to be a whole number but a decimal, and it's going to be somewhere in between 1 and 2. So x is greater than 1 but less than 2. We know this. Now, how are we going to actually solve this problem and find the exact value of x? Well, what I can do is rewrite 16 as 8 times 2. Now what I'm going to do is divide both sides by 8. So then these two cancel out, and I get 8 to the power of x over 8 is equal to 2. Now if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So a to the power of x over a to the power of 1 is equal to a to the power of x minus 1, which is equal to 2. Now a is the same thing as 2 to the power of 3, so I get 2 to the power of 3 to the power of x minus 1 is equal to 2. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 3 to the power of x minus 1 is the same thing as 2 to the power of 3 times x minus 1. And 3 times x minus 1, I can distribute 3, so I get 2 to the power of 3x minus 3 is equal to 2. And 2 is the same thing as 2 to the power of 1. And if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So this means that 3x minus 3 is equal to 1. And now if I add 3 on both sides, I get 3x is equal to 4, and x is equal to 4 over 3. Now, there actually is another way to solve this problem. What I can also do is at the start rewrite both of these in bases of 2. So 8 is the same thing as 2 to the power of 3, so I get 2 to the power of 3 to the power of x, and 16 is the same thing as 2 to the power of 4. Now this is the same thing as 2 to the power of 3x is equal to 2 to the power of 4, meaning that 3x is equal to 4, and x is equal to 4 over 3. So this is a much simpler method of solving this problem. Alright, so in this video, I'm going to be solving the equation 8 to the power of x is equal to 80. So, my only variable in this equation is x, so that's what I'm going to be solving for. And now for my solution. I'm going to rewrite my equation here, a to the power of x is equal to 80. And now, my first step to solving this problem is rewriting 80 as 8 times 10. So now I get 8 to the power of x is equal to 8 times 10. And now I can go ahead and divide both sides by 8. So then these two cancel out, and I get 8 to the power of x over 8 is equal to, all that's left here is 10. Now, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So a to the power of x over 8, well, 8 is the same thing as a to the power of 1. And a to the power of x over a to the power of 1, by using this property, is going to equal a to the power of x minus 1. And this is equal to 10. Now from here, I'm going to take the log on both sides. So I get log of 8 to the power of x minus 1 is equal to log of 10. And the reason I take the log on both sides is because now I can use the property that states that if I have something in the form log a to the power of b, I can move this exponent b to the front, so it's going to equal b times log a. So log a to the power of x minus 1, I can move x minus 1 to the front, and I get x minus 1 times log 8 is equal to log 10. And this property is really important because before, x was an exponent, and it's really hard to solve an exponential equation, but now we moved x, and now it's a real term, and it's much simpler to solve. So now what I'm going to do is distribute my log x here. So now I get x times log x, or log 8, which is equal to x times log 8, minus 1 times log 8, which is just log 8, is equal to log 10. And now I'm going to add log 8 on both sides. So then these two cancel out, and I get x times log 8 is equal to log 10 plus log 8. And now we want to isolate x. So what I'm going to do is get rid of this log 8 by dividing both sides by log 8. So then these two cancel out, and I'll be left with x is equal to log 10 plus log 8 over log 8. Now log 10, that's equal to 1, if you guys already know. So I get x is equal to 1 plus log 8 over log 8. Now, this is the same thing as 1 over log 8 plus log 8 over log 8. And log 8, these two cancel out, so I'm left with x is equal to 1 over log 8 plus 1. And log 8 is equal to 0.9031. So I get x is equal to 1 over 0.9031 plus 1. And 1 over 0.9031 is equal to 1.1073, and this plus 1 is equal to 2.1073. So this is my answer.